Hi everyone, and welcome to this presentation about the new security features of the upcoming 23C release. I'm Francois Pons. I'm reporting into the database product management, and I'm happy to spend a few minutes with you around 23C. This is our usual safe harbor statement. Please remember that this information is precisely just for your information. I'm going to present you with a bunch of features. Some of them were already introduced in the innovation release 21C. Some have been even backported into the latest release updates of 19C, but some of them are truly absolutely new in 23C. As you know, Oracle has had a strong portfolio of security features for a long time, including free features such as auditing, the database security assessment tool, or privilege analysis, which is just part of Enterprise Edition. Also, additional features provided as options on top of Enterprise Edition, the advanced security option or database vault, and even some companion products such as Audit Vault and Database Firewall or Oracle Key Vault for management of encryption keys. So a history of lots of security features, and obviously 23C is strengthening this offering with still more features. And I'm going to give you, or I'm going to try to give you a few highlights about these new features in this presentation. And I see basically two trends to guide these new features. One is about simplification, and another one is about better supporting industry standards. So the first two that this slide is sort of my agenda, the developer role and schema privileges would definitely fall into this simplification category, whereas TLS 1.3 support and integration, better integration with Azure fall into this other category of better supporting industry standards. I'm also going to give you some information about one major feature, which is the SQL Firewall, and a few other things such as support for longer passwords or a way to focus auditing to your sensitive information. But let's get started with the developer role. You know that 23C is nicknamed AppSimple, and basically it is focusing at making Oracle easier for developers, even when they are not particularly DBA savvy, if you will. And developer role definitely falls into this category where we try to make Oracle easier to access for developers. In fact, Oracle Database has more than 280 distinct privileges which fall into different categories. There are system privileges, object privileges. We also have aggregates known as roles. And it's a bit complex for a new developer to know exactly what privileges are needed. And often enough, they fall into the drawback of working with the DBA role, or basically having just too many privileges. Whereas, in fact, they need a relatively consistent group of privileges. And the idea of this new role is to grant a new developer with exactly what they need to implement, design, deploy applications on Oracle databases. So it's a new role that can be granted or revoked by just one simple statement, and it includes all the privileges, system, object, and roles required to design and deploy an average application. If you look at the system privileges that are included, obviously you will see that it allows you to connect and to create basic objects, such as tables and stored procedures and views, but it goes much beyond that, since now a lot of applications deal with analytical queries, and so it allows you to create cubes and dimensions and hierarchies and everything that is necessary for developing analytical applications. But it does not only grant you system privileges, it also gives you object privileges, such as the ones allowing you to check basic database parameters, or to analyzing performance by accessing to some database statistics. And also it grants you what is required in terms of execution privileges on specific packages. So basically everything you need to develop even document-like applications. This SODA app role is what is required if you want to use the NoSQL style API that lets you create and store a collection of documents like in JSON in the database, or the CTX app role that allows you to create text indexes on your data. Now, this is really good if you work on your own schema, but in many applications, you have a schema that is shared by a number of database users, and each of these database users needs access to the shared schema besides a private schema. And in Oracle, basically, we can grant privileges on a different schema than your own through system privileges, but that's a problem because it's too wide scope. You can grant select any tables, for instance, database-wide, but it's a bit too much, and then it lowers the global security of your system. Or if you want to give privileges on just somebody else's schema, you can grant object privileges, object by object, but that takes potentially a lot of efforts. So with schema privileges, we have now a new syntax that allows to simplify things by giving just privileges on a different schema than your own with a simple statement. So, for instance, look at that statement on the right-hand side of my screen. You can grant select any table on the whole sales schema to user Scott. And this way, with just one statement, how many objects there may be in the sales schema, you give access, select access at least, to user Scott with just one statement. And it's much more secure than granting select any tables to Scott, which would grant Scott access not only to sales, but to many other schemas across the database. If you compare what we can do with that statement in 23C to what we had to do prior to 23C, you will see the huge advantage that is provided through schema privileges. And obviously, if you were to grant object privileges, like on the left-hand part of the screen, object by object, what happens when a new object is created afterwards? You need some maintenance, whereas with the statement on the right, even if you add an object afterwards, the select access on this object will be part of the global schema privilege. So two simplifications to make Oracle easier to use for a new developer. And now we're going to discuss two new features that are more focused at better supporting industry standards. And the first one is about TLS, which is, let's say, the industry standard to encrypt the network. TLS, it stands for Transport Layer Security. It's a replacement for the old standard, the former standard, which used to be Secure Sockets Layer, SSL. Actually, I think SSL version 3.1 became TLS version 1. And what it is, it's the standard cryptographic protocol enabling secure communications over the internet. It uses public key infrastructure PKI certificates to, first of all, allowing you to strongly authenticate users and to come up with a symmetric encryption key that allows you to encrypt the TCP/IP network between, let's say, a client and a server. In fact, when you think about an Oracle client connecting to an Oracle database, you have two options, because Oracle Net, the client-server protocol between an Oracle client and the database, is a two-layer thing. At the bottom, it today uses always TCP/IP, but the upper layer uses what we call TNS, which is the abstraction of a protocol that we designed at a time when there were lots of other protocols besides TCP/IP, and we wanted Oracle Net, SQL Net at the time, to be protocol independent. And so still today it is a two-layer thing with TNS on top and TCP/IP at the bottom, which allows you to encrypt at either one of these two layers. And so today there is certainly a push towards adopting more frequently TLS over the so-called native network encryption, which is the encryption offered by the TNS top layer of Oracle Net. And certainly some commercial customers are turning to TLS for improved network security. So although we've supported TLS for a long time, so far it was not very often chosen. And with 23C, we want to make this choice perhaps easier to make. First of all, by supporting the latest standard. In 23C, we dropped support for TLS 1 and 1.1, and we still support 1.2, but we most importantly support the latest and greatest standard, which is TLS 1.3. Also, we've made an effort to make the configuration easier, better documented, and we have simplified the configuration on the client side by supporting what is known as walletless TLS. And I'll come back to that, but basically TLS allows the client to strongly authenticate to the server, but this can be done today as an option. And if you want to simplify the configuration, you can have a walletless. In fact, if you want the client to authenticate, the client needs a certificate, and you need a container for that certificate, which is the so-called wallet. It complexifies the deployment, but now with 23C we support a walletless configuration on the client side, which should make things simpler to just use TLS for encryption, just ignoring the possibility to strongly authenticate the client. If you are considering to encrypt your network, there are a couple of decisions to make. The first one is, at which level do you want to encrypt? Are you going to use the Oracle proprietary native network encryption, or are you going to use TLS, which is more of an industry standard? If you use TLS, remember that the server will always need to present a certificate for authentication to the client. That certificate should be valid and validated by a signature. It should be a signed certificate. And so the second choice you have to make is, how do you sign that certificate? You can choose to sign it by means of commonly known certificate authority, such as DigiCert or VeriSign, or you can decide to sign it yourself. It's called then a self-signed certificate. Another choice is whether or not you want to go for the default, which is mutual TLS, in which case not only does the server authenticate to the client, but also the client authenticate to the server, which means both server and client need a certificate. And if you want to go for the simplified configuration known as just TLS or one-way TLS, which is now possible with 23C, you don't have to create a wallet on the client. The client, when it needs to present a certificate, requires that wallet, which is the container for storing the certificate. But if you go for TLS, you can decide that the client doesn't need a wallet, and that obviously is simpler. Let's review the different choices. One possibility is to use encryption at the Oracle native network layer, and this is sometimes used because it's very easy. You just have to set a few parameters in SQLnet.ora, which is the parameter file for OracleNet, and it can be even done only on the server. And after that, there is a guarantee that either the client cannot connect, or if he connects, the communication will be encrypted by means of a symmetric key that is negotiated at the time of the connection for the duration of the session, and that allows to encrypt your network. It's much better than not encrypting it at all. It's even the default solution that is enforced by some of the Oracle databases hosted on the Oracle Cloud infrastructure. If it's what we call the DBCS, the base system, it configures this sort of encryption for every client by default. However, the second possibility is to use TLS. And this gives you a few advantages. One advantage is that it is more aligned with industry standards, using public key infrastructure technologies. It is also providing, besides encryption, a stronger way of authenticating both server and client to each other. Obviously, the configuration then demands that you create these wallets, which are the containers for the certificates. Mandatorily, there is one on the server side, and optionally, one for the client to also authenticate. Now, potentially, you can just authenticate the server, and the client can take advantage of TLS for just the network encryption, ignoring the authentication possibilities. This TLS solution is also the default for some of the database services when they are hosted in the Oracle Cloud infrastructure, and that's, for instance, what is used by Autonomous Database. Autonomous Database, even by default, offers MTLS, which is why when you create an autonomous database, it generates a package of credentials which you normally download on the client side, and that package contains, among other things, the wallet containing a certificate for the client to authenticate to the server. Now, if you have used Autonomous, you know that we have relaxed this MTLS configuration for some time, and at least under certain conditions, you can do TLS instead of the MTLS. And in that case, you no longer need the client-side wallet. So it depends exactly on which case you are, but if your client is, for instance, already deployed securely within a private subnet, that's one of the conditions that allows the walletless client configuration to Autonomous Database. As the server needs a signed certificate for authentication, you need to decide how you are going to sign this certificate. Option number one is to use a commercial certificate authority such as DigiCert or VeriSign. Option number two is to do it yourself by using a self-signed certificate for the server. The advantage of using a commercial certificate authority is that the root certificate that is required on the client to verify the signature is already present. It is already part of the local trust store because it is the same technology that you use to securely connect by HTTPS to a trusted website. So if your client knows how to connect to a trusted website by HTTPS, it's got already everything it requires to check the signature of a server certificate that is signed by DigiCert or by any other commercial authorities. However, if you go for the self-signed certificate authority approach, then nothing is already present on your client to validate your signature. So you need to install more or less manually the root certificate that would be used by the client to check the signature of your server certificate. And you can use some Oracle tools for doing that, such as Aura PKI, but that demands a little bit of configuration. So to achieve a proper, let's say, walletless client configuration, it's better to use a commercial certificate authority at the expense of having to pay for that service. The way it would work is, first of all, you need to create a certificate signing request and that you address to DigiCert, for instance. Then that certificate authority would verify your identity, and once this is done, will provide you with a signed certificate for your server. And it is important to understand that this configuration can be done once and for all on the server, and nothing is really required on the client. So it's done only on the server. The same certificate can be used for both the database per se and for the listener, since both parts of the database need to be similarly authenticated. And then when the client tries to connect, the server will present to the client both the signed certificate and the root certificate that is used to verify the signature. And because this is already present in the default trust store, the client can simply verify the signature and the connection can proceed. The next feature is also about better supporting industry standards. In this case, it's about authenticating Oracle database users from Azure Active Directory. And obviously, this is also part of our multi-cloud strategy where we want to better support hybrid configurations. So in fact, there were two sister projects making progress along the same lines, and both are about identifying database users externally through an external directory service. And we consider two of these directory services. On the one hand, it could be the identity and account management service of the Oracle Cloud. On the other hand, it could be Microsoft Active Directory. In both cases, users identified from that directory could be directly mapped to an Oracle database. It helps to integrate Azure and OCI, but it also helps to manage users centrally. And obviously, in a large organization, groups of users need to be granted access to a certain number of databases and applications. If you were to create a user individually, database per database, and grant privileges accordingly, that could lead to a lot of manual tasks and maintenance. However, if you introduce a central location to manage these users, for instance, an Azure Active Directory service, you can create a certain individual only once in this directory service, and this individual can be mapped to the applications and databases that he needs to access from that directory service once and for all. So it's all about providing organizations with a way to create single sign-on solutions to the Oracle databases in the organization, and that can be done from Azure Active Directory using a standard solution based on OAuth 2, which in this case, O doesn't mean Oracle for once, it means open, and OAuth is a standard protocol to manage, to carry this identity that is obtained from Azure Active Directory to a target database. Although you could map an individual user that has been like this identified externally to a private schema in a certain database, that's usually not what is the best practice. The best practice is more likely to map a group of users on a certain database to a global schema and grant them privileges through an ad hoc global role. And that can be done with this solution so that should a new user join or should a user quit, all the management can be done from the central location once and for all. So we have a specific syntax to create these shared schemas and these global roles. And as you see, there is always, almost always, the identify globally keyword in the SQL syntax to create these database objects. And the syntax allows to map such a global schema or a global role to a group of users in the central directory. And then you can have a solution where a certain individual gets an OAuth token from Active Azure Directory Service, and using this token can be directly mapped to a global schema and be given a role in a database also through this token and work on the database without having to identify locally on this target database. Obviously, there are lots of Microsoft-centric applications. For instance, Power BI is Microsoft data visualization and business intelligence software. And some customers are keen to identifying Power BI users against Azure Active Directory and connecting them to an Oracle database, for instance, an autonomous database in the Oracle Cloud. So this solution makes this a lot easier. Just in passing, you need to install, obviously, on a certain client above Oracle Net, an Oracle client supporting Microsoft technologies. And typically, today with modern technologies, you would need to install the Oracle data provider for .NET. Interestingly, for now a few months, we've released a way to install this Oracle data provider for .NET from a Microsoft native installer, an MSI installer, which is a lot more user-friendly for Microsoft users. And so when you download this from the Oracle web, here you can see the URL where you can get this Microsoft installer for the Oracle data provider for .NET. It automatically configures both the managed and unmanaged ODB.NET providers. There is a little difference of generation between the managed that is fully written in .NET and the unmanaged version of it, which is partially written in .NET and partially written in C++. So depending on the Microsoft client, you would need to use either the managed driver or the unmanaged driver, but both can be very easily installed and configured by using this MSI installer. One of the most interesting new features of 23C is perhaps the SQL Firewall that you can use to detect anomalies and prevent SQL injection attacks. It's an internalized in-database firewall that can be used to examine all the SQL statements that are submitted to the database, including some session context information, such as the IP address the SQL statement is executed from, and the database can then decide whether or not a SQL statement is expected and should be executed, or wasn't expected and should be logged as suspicious, or even potentially not executed at all. You use this firewall with two phases. In phase one, you teach the firewall what are the expected SQL statements that should be executed. And you do this sort of training by running your trusted application in capture mode. During this capture, the SQL Firewall captures all the SQL statements, including their session context information, and builds an allow list of expected SQL statements. Then in phase 2, you turn the firewall in protective mode with a number of possible options. When an unexpected SQL statement is executed, the firewall can just let it pass and just log it as suspicious. In that case, it creates an audit record in the unified audit trail, or it can even block it completely. In that case, it also logs it in the audit trail. Because it is internalized, it is impossible to be bypassed, and it doesn't create any performance overhead. So it's a great feature to detect anomalies and to prevent a SQL injection attack where a cyber criminal would try to use the weaknesses of an existing application to change the SQL statements that are executed against your database to extract information that the database normally shouldn't return. Another good security feature of 23C is stronger passwords because they can now be longer. Prior to 23C, we were limiting the length of any passwords to 30 bytes, which is good enough on single byte character sets, but for a database using a multi-byte character set, it could be, in terms of characters, much smaller, like limiting your passwords to 6 or 7 characters. It's not long enough. So in 23C, we've extended this length to 1024 bytes, which allows to give technical users in the database that are given automatically a password, for instance, the DataSafe user that's created in OCI to manage the database security through DataSafe. This user can be given a password of 100 characters, much more secure. I'll just finish my presentation by saying a few words about auditing and auditing policies. The first thing I want to say is that prior to 23C, we still were supporting 2 frameworks for capturing audit records. there was the traditional auditing framework initially introduced many years ago in Oracle 7, and that was deprecated in 19C but still supported, and the newer framework which had been introduced in 12C, known as Unified Auditing, a much more secure and much more flexible framework. In 19C you could still decide to use either one, but in 23C you now have to use the better framework known as Unified Auditing. One thing we've added to make it even better is the ability to focus an auditing policy on just certain columns of a table. And that's interesting because when you discover sensitive data, you recognize certain columns as holding sensitive pieces of information. And so if you don't want to be overwhelmed by audit records, you want to focus audit policies on what is interesting, for instance, access to sensitive data, which means access to certain columns of your database. Now that's possible to create such an audit policy, and you see the syntax at the bottom of that screen. That's everything I wanted to show you. Just one final piece of information. If you want to get a feeling yourself by using 23C, we have a free version that's specifically targeted at developers. We call it, for that reason, Oracle Database 23C Free Developer Release. You can freely download it. It gets a few limitations, like you are limited to using 2 gigabytes of RAM, 2 OCPUs, and a maximum amount of storage of 12 gigabytes. But that's already a lot, knowing that you can use compression, and it allows you to discover all these features that I have described. They are part of the free release. Thank you for your attention, and I hope that you will enjoy using 23C.